I can share my experience in a bit.
Okay, thank you very much, Philip. So just to give you an idea about the structure of today's webinar, we will first present to you the program in general, that you get an idea, so that you get an overview of the software. Then Philip will explain to you why it's useful for teaching, as he has got experience in this regard. And then I will show you a few project examples that you see how you can use this software for simulation purposes. So generally, our company, Vela Solaris, has been founded about 15 years ago. It is a spin-off company of the Institut für Solartechnik, Institute for Solar Technology, Rapperswil in close to Zurich. And this Institute for Solar Technology is part of the University of Rapperswil. It has developed Polysun for the first time already in 1992. And since then, the software was developed further and further. Initially, it was only for solar thermal, but then also the other technologies were added. And as I said, for now about 15 years, we are developing the software, and we are also marketing it around the world. It is used in more than 50 countries, at universities, by planners, by system planners, by architects, engineers, by, of course, companies, specialized companies in the field of renewable energies. And the interesting thing about Polysun is that you can combine different technologies with each other. So as I've just mentioned, we started off with solar thermal, but today you can simulate also photovoltaic systems, heat pumps, ground source loops, cogeneration units, and so on. So actually all the systems which might be interesting for building integrated systems. And so you can combine these different technologies with each other. And this we will also briefly see today. So not to lose any more time about introductional comments, I would now like to start. You can see my screen, I hope so, at least. And you usually, when you use Polysun for the first time, you would start with the wizard. And the wizard is not actually what Polysun is about. You will see now very soon the graphical user interface, and you will see how flexible it is. But of course, if you use Polysun for the very first time, the wizard is a starting help. It's a project assistant to get started. And first of all, you can use here, you can choose here the location from a database or from a map. So we have worldwide weather data integrated in the software. So you can, for example, choose here from Europe, from North America, Asia, Oceania, wherever you are. Or you can choose from a map. So here, for example, you can also write the name. And then automatically the cursor goes to this place, and you can confirm it. Then you can click on continue, and you have the possibility here to choose your system according to the energy providers and the loads. Polysun contains about 1,000 systems. So as the choice is enormous, of course, this filter helps you a lot to choose your system. So for example, if we want to start with a solar thermal system for domestic hot water, for example, then you can do your settings here and you will see the available system templates on the right. If you hover with the mouse over them, you can see the hydraulic layout, so you can choose a system which is suitable for your purposes. So you confirm that, then you can do some settings for domestic hot water here, but you can do more detailed settings later on when you see directly the graphical user interface. So you click on continue, then you can choose your collector here from a huge database. We have got all collectors here with solar key mark, so you can choose your collector from this database. And then once you have chosen your collector, then you can set the orientation here. As you can see from this graph, south is 0, north is 180, plus 90 is east, and minus 90 is west. So for example, if you are in Australia, as we have chosen now a location in Melbourne, the orientation would be typically north. So it's 180, and then you can adapt the tilt angle here. And Polysun suggests you a certain number of collectors for the template which you have chosen and the location, and also a certain tank volume, which you can also adapt here from the database. You can you have also all sorts of tanks, of all sorts of storage tanks here, and you can choose them directly from the list. You confirm. You can do the same for the heat generator. But as I said, I want to really to show to you the graphical user interface and not show you too long the wizard. I want to proceed. So after you have completed the wizard, you will automatically get the first results. The simulation has run. You see here 6.8 seconds. The duration of the simulation depends upon the system. If it is more complex, of course, it will take a longer time. But this is a very simple system, so it's really very fast. And of course, the short simulation time also enables you to compare systems with each other very quickly. So first you get this results overview, but this results overview is very, very general. So you can go here into the menu results and have a look at more detailed results. For example, here the system results, where you get a good overview of the system. You can see here, for example, the energy demand. Then you see, for example, here the solar radiation onto the collector area, the solar yield, solar thermal yield of the collector field. You see here the solar energy which goes to the tanks. You can check, or to the tank in this case, you can check the solar fraction. So many values here, how much energy is supplied by the heat generator. In this case, we have a gas boiler. This is, as I said, an overview of the system. If you want to know further details, you can go into component results, where, as the name already says, you will find single values for the components, not for the whole system. So you will find some more values which you were not able to see before. For example, the temperatures for the collector, the the average temperatures over 24 hours, the temperatures during operation. You will see, for example, also for the storage tank, the single temperatures, and you will notice here we have 12 layers. That is necessary to simulate also the stratification of the tank. Now here you have these temperatures of the single layers. Now you might say, I'm not interested in the average temperatures for each month. I want to know the temperatures of certain moments. Then you can go deeper. You can go into the graphical evaluation, and you can, for example, choose a week here. Then you can click on add curve. You can, for example, then choose certain values which you want to see, like, for example, the collector field yield. Then you can add a further curve, and then, as we have just seen, the storage tank has 12 layers, so I want to know what is happening in the lower layer and what is happening in the top layer. For example, now we have obviously 2 units, so we should change axis. Now, of course, this is not so easy to see for you yellow, so we can change the color. And then you can see, for example, what is happening in the system during this week. You see here in red the collector field yield. You see, for example, here on this day, the collector field yield is not as high, and you see how the temperature in the lower layer of the tank drops, but in the upper part it's kept high, of course, thanks to the boiler. So the graphical evaluation is really very nice because you can analyze the system in detail, and you choose the values which you want to see. You see, we have many different types of results. The time is limited, so I cannot show them all to you. And we will see, of course, some of them again when we have a look at the project examples later on. But one more I want to show to you briefly, that's the simulation analysis, because if you want to go even deeper into the software, then you can have a look at the simulation analysis, which will show you the results of the single time steps. So you see here exactly what is happening in the system, and you see that we are talking about a very detailed simulation. It's not it's not an hourly simulation. It's even more detailed. You can see this here from the number of time steps. You know very well that a year has got 8,760 hours, but already here on 9th of January, we are still very early in the year, we are already at simulation time step 4,337, and you can check exactly the temperatures, the flow rate, the power here of this collector field in that very moment. And you can see, for example, here 9th of January, 9:34 and 35 seconds. And when you click here on plus, you see the next time step. So you see also, you see exactly the length of the time step. It's like here 75 seconds, again 75 seconds, but the length varies according to what is happening in the system. So for example, now here at 10 a.m. We start to consume domestic hot water. You can see this here, and then you see the next time step is only 10 seconds long. So it depends upon the situation, how long the time step is. It's a dynamic simulation. So we have got here 6 menus. You have already seen the results menu, at least some examples of it. We have also system diagram and project. There's not much to say about this, but quite interesting also the menu for the catalogs. We have databases of all components in Polysun, not only for the collector, you see here the enormous amounts of databases which we have in Polysun. So you can choose from a vast array of components, of products which really exist on the market. And additionally, you can also add your own components if you don't find what you're looking for. Options, you can here choose your language, change your currency, and so on. For example, for the financial analysis. And also we have a user manual. The user manual, as you can see, is almost 300 pages long. So as there's a lot of information also in this user manual, you can see this here from the contents. We have here photovoltaics, solar thermal, heat pumps, other components, controllers. We will have a brief look at them as well, the different simulation results, profitability calculation, and so on. And we have also videos. And you can click directly on these links. You see they are directly linked with YouTube, and you can watch them and also get an idea of more topics in Polysun. And if you open the German manual, you will find even more. So if you know some German, there are even more videos in German. So this is the graphical user interface which I wanted to show to you. That is really what Polysun is about. You usually work with the graphical user interface, and everything you see here on the right side in the design area is not a picture, it is an interactive area. You can click here on all the components, and when you click on a component, when you double click it actually, then a dialog window opens and you will see here the symbol for the database. You can then open again the catalog, what we have already seen briefly before with the solar thermal collectors. But as I said, not only for the solar thermal collectors, we have catalogs also for the tank. You already saw this. Of course, also for the boiler. You have here different fuels also. You see gas, oil, pellets, firewood, and so on. You can change very easily from boiler to heat pump to air source heat pump. We have also here an enormous catalog of air source heat pumps, which are defined through the reference points, heating power at certain temperatures, electrical power at certain temperatures. And even for the pipes, we have a database with different diameters, different materials, and so on. So it's very, very detailed and very nicely done, because clicking on it, you can exchange the components. This also is regarding, for example, domestic hot water. You can do your settings here, different values for different months. You can define a daily profile, and so on and so on. So this design area is really crucial for Polysun, and not only you can exchange all the components here, but with the Polysun Designer and also the educational version, you can also edit these systems. So for example, here you can now copy a system. We can give it a different name, but now for time reasons, we don't do it. And for example, now if you want to edit this system, now I will do a very quick example. And let's say we don't want to have this three-way valve here, this mixing valve here, then we can click on it, we can delete it. And so you can edit these systems, and you can do this with all the systems which we have, 1,000 systems. So this way, of course, you can create many more systems than you actually have here. And now you can simulate the system again by going on to results without the three-way valve. For example, a very simple example to be able to show it within seconds, but of course you can do also more complex issues. You could even start with a blank page, and with the help of these icons you can create your own system. Of course, you have to connect the single components with each other, and you must make sure that you put the controllers and that you set them properly. So this, of course, is very important. We have many different types of controllers in Polysun. You can see here an overview, and we have also the very powerful programmable controller, which allows you to not only to set temperatures and choose the sensors, but also allows you to define freely the control logics. So the controllers are really also very, very important in Polysun. And we have also a profitability calculation where you can do all your settings of the system. Now, well, the simulation is running again because I took out the three-way valve. But anyway, just to show this very briefly to you, can set here the conditions, of course, the electricity prices, the system costs, operation maintenance, even if you have to pay interests for a loan which you might have needed to finance your system. So you have got here all these possibilities. Once you have done all your settings, then you can compare the systems with each other. This I have prepared, of course, because now we don't have the time to do all this, but you can compare different systems with each other regarding the profitability. And here we can, for example, see that we have 3 systems where we have to do some investment compared to another one, which is here the black one. But then after some time, these systems are more profitable than the old system, thanks to the energy savings and of course also the savings in terms of costs. And it's also interesting, it's also a question, when do we pay back the system? This here, for example, the red system pays back earlier, but on the long run, the yellow system is even the most convenient. So it's not only a question of does it pay back, but also when. And of course, then we can ask, for example, the client when, how much time does he have, how patient is he, when does he want to have it paid back. So that's obviously then also a very personal issue. I have talked about all these templates, and here you can see the list of the templates. On the left bottom, you see here different folders, and we have lots of templates inside here. And you can also load these templates directly from here. So you don't have to start with the wizard. Once you know your Polysun well, then you can load them directly from here and then do all your settings by double clicking on the components and work this way with Polysun. You can also create here your own folder of favorite systems so that you don't have to look for them once you know your way around in Polysun. Here you have some special systems, and here you have company templates which have been designed for companies. You can see their names, and you can use all of them. Also in the educational version, you can use all of these templates. So there is really an enormous amount of templates and an enormous amount of products inside, which also, of course, gives the students a very good overview of the market. And the student can very quickly compare different system configurations with each other. so can very easily understand how renewable energy systems work, which of course, especially for a student, often is rather difficult if he has no work experience, which of course is normal at a young age. So it's this software is very helpful really to get an idea how systems work, and as we have seen, the simulation times are short, so he can quickly compare. So this would be a very rough introduction into the software. The software is very rich. You might have gathered already an idea, but that of course it's now well, you will have a chance to test it, to have a closer look at it, and then you of course we are always available to introduce you personally into the software, that you that we will also be able to answer your personal questions, because you might have different interests. So that there will be a chance also to do that. Today is just a chance to give an overview of the system. And before I present a few project examples, I would like to ask Philip regarding his experiences with Polysun, especially when it comes to teaching.
Yes, thank you, Andreas. I have used Polysun in 2 different environments. Like, I first came across Polysun when I was working for a business development unit in a big German company, and we tried to sell solar heat and solar electricity systems for industrial processes. So there I used the full range, and we got the actual load profiles from the companies. So it is possible to do super detailed analysis of things. But what I really liked in the teaching was you load one of these templates as a student, and you have 0 idea, not quite 0 idea, because you need to be a good teacher. So you have no idea what the system is all about, but you start to see results, and you start to see if you start changing things. You change the temperatures, you change the electricity output, you change the number of panels, and so forth. You can very easily get first results, and then ease yourself into more complex situation quite well. Like, I've used it now 2 years in a row with a group of students, like in summer schools. And yeah, summer school is 2 weeks, so the students don't really have too much time to get experts. But after 2 weeks, I got like fantastic results from the students. I usually like this year it was a pandemic induced online course, and it was fantastic. So the students could share their screens with each other. You have these subgroups that can work with each other, and they can really produce meaningful output. And I had 10 different groups and 10 very different systems, and the students were free to like really come up with ideas, come up with like innovative solutions, and find a template that was like roughly fitting, and then they custom make it. And I was impressed by what the students were able to get out of it. And then of course, on a later stage, if you want to use this in the real world, you get more and more detailed. So yeah, I was impressed by how this way of modeling things really inspired the students to be creative and innovative. So Andreas, if you want to show the
Yes, thank you. Thank you, Philip, for these insights from an insider. So this is really very important. And yeah, it's really about learning by doing, you know, because obviously a student is also more motivated if he can do something practical And this is obviously sometimes the problem if he's studying in books and reading, and it's difficult for him to imagine things. But now with the software, he really feels more a part of the lecture, and for that reason, it's really a great tool to be used during the lecture, and a great
If I may add something,
Yes,
it's
please,
like
please.
especially in online learning, like I was amazed how engaged they all of a sudden got. Like I was thinking during the online lectures they were all falling asleep, and then I start the practical work, and then all of a sudden there was like, oh, professor, how do you do this? And like there was like real interaction, and it was
Yes.
a really good experience, especially in the online environment, which we will see more of now, I'm sure.
Yes, indeed. And currently, of course, we are doing practically all by online, and it's all around the world. It's like this, or well, or at least in most of the countries, direct personal lectures are not possible at the moment, or have not been possible for a long time. So especially in these situations, of course, the software is perfect, because you the students, as you have said, get engaged, and that's great. I mean, because everybody of us also knows how difficult online lectures are for the teachers and for the students, because we don't see each other. And so it's it's really a perfect way. So thank you very much again, Philip, for your insights. Now I will show you, as I have mentioned, a few examples. So I have prepared something for you. You see the project is opening now. And so let's imagine we have this house, and this house is now placed in Adelaide, for example, and now we can simulate this house in different ways. For example, first we have got simply here a heat pump with a tank, and we want to simulate only domestic hot water, not heating, as we don't have any heating in the house, let's say, as it is rather common in many Australian houses. We could do just the thermal simulation here as a first step. And then, of course, we could have a look at the system results. So the system now here is running. And here, then, the thermal results are shown. The most important issues here are, for example, the total energy demand. As we have said, this is only domestic hot water. You see here a higher demand in late winter because the cold water is colder. So, of course, we need more energy to reach the same hot water temperatures than in summer. We have also here then the chance to see the thermal output of the heat pump and the electricity which is required to drive the heat pump. Of course, you can check these results even more in detail in component results. We can go here into heat pump. You see here again also the temperatures. Again, of course, these values which we could check already in the system results. We see also the average performance factor of the heat pump. We can see, for example, operation times and the time it switches on, and many other issues, as we have already seen briefly. Now, this would be the starting point, just a thermal system, but now the house owner wants to integrate the system, and he wants to consider everything in the household, not only the thermal part, but he wants to take into consideration also the electricity consumption. And this we can set here, for example, through this icon. we can have here a catalog with different load profiles. Here we have, for example, the residential profile for Southern Hemisphere, and we can include the electricity consumption of the thermal components. This is very, very comfortable in Polysun because Polysun, as it is doing anyway the thermal simulation, which I've shown to you now, Polysun knows exactly when and how much electricity is being consumed by the heat pump. So we don't have to invent a profile because anyway it would be wrong or it would be very rough. Polysun knows this exactly for all the time steps, and then of course we add the profile for the domestic appliances, which here is, for example, 3,500 kilowatt hours. But of course, it's not one value. This is just shown here. There are thousands of values to define the consumption in the household, then match together with the heat pump. We get the total thermal and electrical, and we say we add now a PV system. Okay, I haven't shown to you today how you define the PV system, but it's really easy, and of course you can edit. So it's usually much easier to simulate PV systems than thermal systems. And then you go again onto system results. You have a look how the system works with the PV system. And then you see now we get two tab sheets in the system results. We get the thermal results and the electrical results. And if we look now at ETOT, which is the total fuel or electricity, or of course in this case it's only electricity, electricity consumption, then of course a positive value means more consumption than production, and a negative value, as it is consumption, means of course more production. So we can already see here a balance. I go quickly back to the previous system, which you have seen. Sorry, I got now the wrong ones. The system results, of course. So if you look here we have, of course, only the electricity of the heat pump, and you see, of course, it's all consumption. But now we have added the PV system here, and so here we have the overall balance, and we see, for example, in summer we have more production, so the consumption values are negative, and in winter we have still more consumption. But now this, of course, is only a general overview. Then we can go much deeper and really see if we can match the consumption and the production. And of course, if we look at it at first sight, and we have a total electricity consumption, so heat pump and household together, of 4,272 kilowatt hours. But and we have, if we look at this, a photovoltaic yield of 5,457 kilowatt hours. So if we look at it at first sight, oh, we say that's great. Our photovoltaic yield is much higher than our consumption, and at first sight we might think the thing is fine and it's done. But of course it's not that easy, because it's a question of matching consumption and production, and that is possible thanks to the time step simulation. And we see indeed here that it's not all that easy, because we have a self-consumption. So that means when we have consumption and production at the same time of only 1,860. So it's not at all so positive. And if we then compare the self-consumption with the total electricity consumption, we have a degree of self-sufficiency over the year of about 43%. So that means, of course, we still need a lot of energy from the external grid. We can obviously also look at it from another point of view. We can also compare of the total yield which we have, how much is self-consumption, and then we have the self-consumption fraction, which is this value. So
if I
our
may
house
add one
own
thing here,
sorry,
to put some Australian context in here, with the new regulations that PV plants are allowed to be curtailed, these kind of simulations are getting more and more important. Like AMO has, I don't know, a month or two ago released this new regulation that newly installed photovoltaic plants can be shut off. So if you design the plant well, that you have a lot of self-consumption in it, then it doesn't matter what AMO does. So this way, it's a way to like easily teach the students or the engineers or whoever are using this to see the benefit of like a complex design of a system. Just to put this into a bit of Australian context, recent news, so to say.
Yes, thank you, Philip, for adding this comment. And you see indeed here that you can not only check how much energy you need from the grid, but how much energy you will feed into the grid with this system. And that's, of course, then also crucial. Now, again, here we see the monthly values, but of course, you know, we can also check the detailed values. And regarding the curtailment, we can also, in the electric grid, we can also limit this here according to the national regulations. So we can have like also a feed-in power limitation, and here we haven't set it, but we can set it. So then of course things will be different again. But now our house owner says, okay, I still need too much energy from the grid, and I also feed too much energy into the grid, although, as we have seen, my PV installation is producing more in total over the year than I am consuming. So he says, I want to add a battery. And so he tries out a simulation with this small battery to see what happens. He clicks on system results, and we will see in a moment what's the situation. And so we go directly here in electrical results. And now you see you have a difference between self-consumption and direct consumption. Direct consumption is what we get directly from the roof, what we consume directly from the roof, of course, via the inverter, that's clear. And self-consumption is now including also what is first stored in the battery and then being consumed. And thanks to that, we get, of course, a higher degree of self-sufficiency. It's 58% now compared to the 43 which we had before. But still, of course, we still need a lot of energy from the grid, and we still maybe feed too much into the grid. So now our house owner decides to put a larger battery, and then let's see what will be the result this time. And we look at the electric results, and now it's totally different. You can see here we have now we are almost self-sufficient. We are over the year of more than 80% in summer. So from October, well, not even only summer, even spring, from October till March, so half of the year, we are almost really self-sufficient or with values around 95%. And you see now we need only very, very little energy from the grid in these months. Only in winter, of course, it's more problematic, but in summer it's really perfect. And in winter, of course, the other way around, we feed only very little into the grid because the battery can take it all, and then well, we still need to add some, but of course, overall, the situation is much, much better. You see also the self-consumption fraction is really high, 76%. You can also display this in a system comparison, that you can see these values all together. So let's have a look also at them. Now, one system we haven't simulated so far, so that is simulated again. Now, for example, if we want to see here the electricity which we have here, for example, we can all check these values, especially the first one is interesting. What we need from the external grid, we can see very well in a clear comparison here and see how different these values are according to the different settings, or also what we need to feed into the grid. So we can see this at first sight. So this would be an example just for domestic hot water, but we have also the possibility to simulate heating and cooling, as it is this case. Here we have domestic hot water, heating and cooling with an heat pump. And we have also now here, for example, a PV system, and here PV system and battery. And we can, of course, also do the simulation in this case and have a look. This is now, of course, a much more complex system because we have many more consumers. It will be more demanding to reach a high self-sufficiency, but of course, Polysun can help us to design this system well. And you see, of course, here first of all, also the total energy demand is really different. We see, of course, the base load by domestic hot water, but then here we have a little bit of heating requirements in winter. We have more cooling requirements in summer. And if we look at the electrical results here, for example, we reach a degree of self-sufficiency of 63%, but of course it depends upon the system, the dimension of the system. So of course it's not so easy to say this, or it's not possible at all to say this in general words, but just to give you an idea here. So this now is an example for PV and heat pump. Now let's also, because already the time is over actually, but before we will stop, and we will give also you the chance to ask some questions. So I want to show to you also a system for solar thermal. And of course, you can combine them also with each other. You have even systems here, like for example, if you look at this here, you have solar thermal, air source, heat pump, and PV all together. And we have also PVT, so that it's all very flexible, as I have already mentioned several times. And here we have process heat, for example. So we have a system with a very large solar thermal field. You see here 120 collectors, total gross area 240 square meters. And we see here the thermal output, again, the solar fraction of the system. And all this is now, for example, for process heat. We can define the process heat here in a very easy way by the inlet temperature, the outlet temperature, and the power of the system. Here the value is negative because obviously energy is taken out of the system. This component can be also defined as an energy source, and then the value would be positive. We can also use a profile. And then we have here, for example, CSV files, which we can define. So you can define different inlet temperatures, different return temperatures, different power requirements. So this to give you an idea of a few projects. Now I would like to ask you if you have any questions. You can post these questions. I'm seeing the questions now. I have only noticed now that one participant says he could not understand me. Well, I hope this has not been the case for everybody. In any case, the webinar has also been recorded, so you will receive 24 hours after this webinar a link where you can download the recording of the webinar. So it's not lost. I'm sorry for the technical inconvenience at the beginning. One question is, for example, regarding the different types of application of Polysun. I think I have explained this throughout the webinar. It can be used for all sorts of building integrated technologies, but also for large PV fields. It is possible. So it's very, very flexible actually for all renewable energy systems. You can also have very large systems, as you see now here, this with this solar collector field. We have also very complex systems. If you run here through these systems, you can see here that they are also very complex systems. And thanks to the design, you can really actually design anything. Please be aware that the educational version has the same features as the designer version, so it has the same potential. It has only a total different price, but of course it's also only sold to universities. So are there any other questions right now? If you have them, you can post them here. Otherwise, as I have said, you have got our email address. You can contact us anytime if you have further questions at a later stage. And we can arrange then also individual screen sharings to deepen the topics in which you are interested. So if there aren't any further questions right now, I would like to thank Philip for his participation, for the very important insights which he has given us, and why Polysun is really very useful for teaching at universities, but also for research. It can be used as you can do very complex systems, as we have seen this. So yes, please get back to us if you want to know more about the software. And for the moment, I thank you very much for your participation. Bye-bye.
Bye-bye.